All right, this video is going to be the second part of Notes 30, Part B, specifically dealing with these problems at the bottom on lines. All right, so problem number 4, write the equation line that is perpendicular, love that key word. All right, perpendicular to the line y equals negative 4x, passes through that point. So in this problem, right now, your slope is negative 4. If you want to get super specific, it would be negative 4 over 1. So what has to happen for your slope for perpendicular lines, right? Keyword there, perpendicular. You need opposite reciprocal slopes. So currently your slope is negative, which means the opposite is going to be a positive. No, you don't actually have to write that down there, but I'm just putting there so we know. So it's positive, and then you got to take your fraction, it's opposite reciprocals. So flip it over. So my slope is going to be 1/4. And it needs to pass through that point 3, negative 5. So we've got point slope formula. Y minus y1 equals m times x minus x1. So y minus negative 5 equals 1/4 times x minus 3. And there's nothing in this problem that actually says I need to go any further. Just as to write the equation line that's perpendicular, I've written an equation. So here's what I'm going to tell you. I would be okay with you stopping here, but I am going to go ahead and keep going to put it into slope-intercept form in case you do have to deal with that at some point. So negative 5 would be y plus 5. Go ahead and distribute the 1/4. So 1/4 x minus 1/4 times 3 is not going to work out too pretty. It is going to be the fraction 3/4. So let's see what we can do here. I'm going to subtract 5 from both sides. So y is equal to 1/4 x. Now off to the side here, I'm going to do negative 3/4 minus 5. I can write that over 1. So common denominator here would be 4. I didn't have to change this first fraction at all. To get from 1 to 4, I had to multiply by 4, so that's going to be 20. So negative 3/4 minus 20/4 would be negative 23/4. Okay, that is definitely not going to be a fun a line to graph, but as far as writing the equation, yeah, this is going to work. Okay, so that's the perpendicular part right there. And let's go ahead and go down to problem number 5. Now, I'm asking for two things. I want you to graph the lines. So we have a line A and a line B. I'm going to go ahead and start by graphing those. So x equals a number. This is going to be a vertical line. Specifically, it is a vertical line. Find the x-axis here. So 1, 2, 3, 4, 5. I'm counting to the left, so it's negative 5 here. And I'm going to draw a vertical line that goes through the x-axis at negative 5. Now, I extend it well beyond the grid, so it's really easy to tell where that is. And not only that, I'm going to label it so I know exactly which line is which. The other line is y equals 2, and I'll do that in, I guess, blue, sure. This is going to be a horizontal line. Okay, so x equals a number is a vertical line. Y equals the number is horizontal. So I'm going to go ahead and go straight across here. And that is y equals 2. Okay. And the second part of the question, right, kind of buried here, it does say to find the slope. So let's talk about the slope of a vertical line. Now, slope, as a reminder, put it off to the side here, right? Slope is rise over run. So how far you change vertically over how far you change horizontally. So here's the problem. If we have a vertical line, we've got plenty of change for rise, but we don't run at all. There's no horizontal change. So all vertical lines have a slope, and I'm going to put this in pink, okay? So M for slope is undefined. Hold on, I can't spell tonight. Undefined. Oh, I was getting it close. Okay, undefined. And that's going to happen for any vertical line. All right, there's plenty of rise, but 0 run. So dividing by 0 is undefined. That's why it is what it is. Now for horizontal lines, we have lots and lots of run, right? Lots of change horizontally, no change vertically. So the difference is, in this case, you would have 0, right? No change in your rise over whatever change in run. That, right, 0 divided by something, slope is 0. So all vertical lines have an undefined slope. All horizontal lines have a slope of 0. And that all goes back to rise over run. So that's problem number 5, part A and part B. Problem number 6, I want to graph the line. This is in general form. Love the format for writing the equation. Not a huge fan of this format for actually graphing it. So let's go ahead and get y by itself. So I'm going to subtract 3x and subtract a 6. Those two things are completely independent of each other, so they don't affect each other. You can do that at the same time. And then I'm going to go ahead and divide every term, right, every piece of the equation by -2. So let's see, a -3 divided by a -2 is going to be a positive 3 over 2x. -6 divided by -2 makes positive 3. And I'm going to go ahead and graph that. So y-intercept is positive 3. And then from that y-intercept, I'm going to count up 1, 2, 3 up, and 2 to the right. If I try to do that again, I'm going to go off the graph. So, right, 1, 2, I'm off the graph, so I'm not going to do that. But instead of going up and to the right, I can count down and to the left. 1, 2, 3, and then 2. 1, 2, 3. Hold on, count right. 1, 2, 3, 1, 2. Down 3, 1, 2, 3, 1, 2 to the left. And again, ran out of graph. So using all of those points, I can play connect the dots. Makes a nice line there. Arrows at the end. And that is graphing that line. All right, so lots of practice on a few different things here for lines, dealing with slope, perpendicular, writing equations, graphing. As always, if you have any questions, please let me know. Otherwise, I will see you in the next one.